In this video, we're going to solve the given system using LU factorization. So let me just remind you that when we have a system like this, we can actually write our system of equations as a matrix and vector equation of the form AX equals B. Okay, so in this case, well, the matrix A always is the coefficient matrix. So in this case, A is 2, 1, 3, 4, -1, 3, and -2, 5, 5. So that's our matrix A. The vector X, of course, is the unknowns we're looking for, X1, X2, X3. Okay, so that's the vector X. And that has to equal the right-hand side vector, which in this case is 17, 31, -5. Okay, so that's the vector B. Now, if you look up here in the upper right, excuse me, the idea behind using an LU factorization is this. If we can take the matrix A, and factor it into an L times a U, then we have L times U times X equals B. And if we let, so let me see if I can fit this in on the side. If we let U times X equals some unknown vector Y, then this becomes L times Y equals B. Now, we know L and U, those come from our factorization. We know what B is, so we can solve for Y here. Once we obtain Y, then we can take it and put it here and solve for X, which is our ultimate goal. Okay? So again, we take our matrix A, factor it into an L times a U. We replace U times X. We substitute for that some unknown vector Y. We find Y first, and then take that value and substitute it into the equation UX equals Y, and find X from that. So let's go ahead and carry that out for this particular situation. We have there our matrix. You can see the matrix A in the upper left. And in the upper right, I've put the LU factorization that we obtained in an earlier video up there for us. So again, remember the whole idea. We have AX equals B. We substitute for A, L times U. We let U times X equal Y, so we have L times Y equals B. And that's what we want to solve first. And then once we have our Y, we go back and can find the X. So if we look here at our L times Y, here's what L is. It's 1, 0, 0, 2, 1, 0, -1, -2. That is not supposed to be a 0 there. That's supposed to be a 1. So let's fix that. So 1 in this spot here. Okay, so there's L. Y is unknown. It's Y1, Y2, Y3. B is the vector 17, 31, -5. So we can see from looking at this that we have three equations. The first equation is Y1 equals 17. The second equation is 2Y1 plus Y2 equals 31. And the third equation is -Y1 minus 2Y2 plus Y3 equals -5. So it's clear from the first equation that Y1 is 17. If we substitute that into the second equation, we have 34 plus Y2 equals 31. So Y2 is -3. If we then substitute those two values into the first equation, what we have, or I'm sorry, into the last equation is we have -Y1, so -17, minus 2Y2, but Y2 is -3, so that becomes +6, plus Y3 equals -5. So you can see on the left-hand side the -17 and the 6 become -11. We add 11 to both sides, and we get that y3 equals 6. Okay, so let me see. I'm going to just put our vector y here in red. Okay, so now we can see that y is, let's see, y1 is 17, y2 is -3, and y3 is 6. So we found y, and let's go on in the next slide here, and we'll see how to go ahead and find x, which is our ultimate goal. So again, let me just remind us, the whole idea is we have ax equals b. A becomes L times U, so we have LUX equals B. We make the substitution U times X equals Y at this point, and that gives us that L times Y equals B. So this last equation, Ly equals B, we solved in the previous slide, and this is the Y that we ended up coming up with. Okay, so now that we know our Y, we can take it and put it in here and figure out what X is. Okay, so what we have is the equation UX equals Y. So let's see, UX equals Y. Let's put the pieces into that. U is 2, 1, 3, 0, -3, -3, and 0, 0, 2. X is x1, x2, x3. And y turned out to be 17, -3, 6. So from this we have three equations. The first equation is 2x1 plus x2 plus 3x3 equals 17. The second equation is -3 x2 minus 3x3 equals -3. And the third equation is 2x3 equals 6. So we can see from the 2x3 equals 6 that x3 is in fact 3. Now we can put that into the equation above it. So when I substitute in 3 for x3, I have -3 x2 minus 9 equals -3. We add 9 to both sides. We then get -3x2 equals 6. So x2 then is -2. And let's see if we can just fit that last one in. So we've got values for x2 and x3 now. So we have 2x1 plus x2, which is -2, so -2, and plus 3x3, and x3 is 3, so that's plus 9 equals 17. Okay, so the -2 and the 9 give us 7. We're going to subtract 7 from both sides. Okay, so when we do that, we have 2x1 equals 10, and x1 equals 5. So our goal, of course, was to find x1 and x2 and x3. And so our final values for those, the vector x that we were looking for, x1 is 5, x2 is -2, and x3 is 3, which is the solution to what we were looking for to begin with. It's the solution to ax equals b, where a and b were known. So that's how we go ahead and use an LU factorization to solve a system of equations.